Hello, hello, hello. Welcome back. I hope those of you who did the ESAT found it okay. I know some of my students found it very, very time pressured. So hopefully you didn't find it too bad. Hopefully, if you did do that test, you were able to use that multiple pass technique that I talked about to try and get through at least the first pass to the end and pick off the low-hanging fruit. So now that that's over, what I've got coming up, I've got one student doing the PAT test next week. So I'm going to do a live solve of the PAT test today. And then coming up after that, for the January cycle, I'm going to be doing more ESAT. I'm also going to be covering some TMUA content. And then also, as we move into December, starting an Oxbridge interview / Imperial engineering interview sort of series, going through what I think makes a good interview and how to show your best work there. So today, I think it's going to be much easier going through the PAT test than it was with the ESAT because it's much less time pressured. So the modern PAT test has 40 questions in 2 hours, which makes it roughly 3 minutes per question. So you have double the length of time that you had for an ESAT. And it means you have less specific exam technique required to get all the way through it. One way in which it's different, though, if you haven't seen, is that not all the questions are worth equal marks. So most of the questions, because if it's 100 marks for 40 questions, and not every question is worth 2.5 marks. So what they do is have most of the questions be worth 2 marks, but some of the harder questions are worth 3 marks and 4 marks. So I'm going to go in with a sort of complete live solve. So I don't know for certain this is what I'm going to do, but I imagine what I might do is do all the 2 markers first because they've kind of been designated as the easy ones. And then once I know I have enough time, I can then come back and do all the 3 mark and 4 mark questions without the sort of pressure of having to get through everything. But we'll see. Maybe if I see a 3 marker or a 4 marker I really like, I'll get into it then and there. I think I will take split times, but I don't think it'll be as important as it was for the ESAT. It'll be more so I can see if there was anything that kind of slowed me up, anything I should work on. I think that's about it. So without further ado, let me get my screen shared. Hold on, let me move you into here. If I realize that I've forgotten to introduce something, then I'll kind of introduce it as I'm going. But in the meantime, let me just do the usual. We'll get the screen shared. And we'll get going. Oh, tablet. Hold on. Please excuse while I plug the tablet in. Okay. Oh, sorry, that is important. So the online calculator, because the PAT test is a calculator paper as opposed to the ESAT, which is non-calc. So if I show you, I'll burn a little bit of time showing you how the calculator works and what I think is important there. So 2 things to note about the calculator. First of all, you can use it 2 ways. You can either use it by clicking the numbers with your mouse, or you can type. But if you are going to choose to type, you have to be aware that there is a certain sort of frame rate for the calculator. So if I quickly go through 1 to 9, it looks like this. Because I went too quickly for it to register on the keyboard that I typed the number. So it's just something to bear in mind. You have everything you need. We can do fractions. We can do logs. Close the bracket. Press the down arrow. Or sorry, click the down arrow. Brings me to the bottom where I can do sine 90 equals number. So everything you need to do on a calculator, you can do here. I'm going to try and use the calculator as little as possible because it looks annoying, but if it ever is required, I'll get that done. Okay, so moving through, let me start the time on my end, even though I've burned through a little bit of time already. I'll keep doing the working here just in case I need to review anything. let's get into it. So question 1, what I see is that things are moving up as powers of 5 on the bottom. So it's 5 squared, 5 cubed. I imagine that was 5 to the 4, which was 625. So 5 times that, it would have been 15. And then 31. Okay. So 137. We're doubling and adding 1 each time. So the next number will be doubling that to 62. That will make it 63 over that times 5, which looks like from the options, it's going to be 15625. I'm also going to zoom in because I worry that that's not going to be big enough for you to see. Okay, so that's 63. And we have the same issue with the bubbles extending the whole way across the screen. So I'll make extra certain I've clicked the right one. No need to flag. Let's move on. Take a lap time. So yeah, definitely less time pressured. Okay, but this is the 3 marker, but it's math that I'm confident in, so I'm going to take it. If that is that, the integral of y. Well, let's find y. So this is boundary conditions, which will be required for my plus c. So I know that dy dx is equal to x squared plus x to the minus 3. So y is going to be the general integral of that, which is a third x cubed. Raise that to minus 2. Divide by minus 2 plus c. Put in the boundary conditions. Y equals 0 for x equaling 1. So a half minus a third is a 6. So we know that y is equal to a third x cubed minus a half x to the minus 2 plus a 6. And let me find the integral of that between 1 and 3. So I'm going to integrate that. So it'll become 12th x to the 4. Raise that to minus 1. Divide by minus 1, it becomes plus a half. Plus a 6x, and that's going to be between 3 and 1. Let me take... Now I'll just plug it in as is. So that becomes 81 over 12 plus 1 over 6 plus 1 over 2 for when I substitute in the 3, and I'm going to subtract off from that a 12th plus a half plus a 6. Let me get these all over 12. 81 over 12 plus 2 over 12 plus 6 over 12. Going to knock off from that 1 over 12, 6 over 12, and 2 over 12. And nope. No, go back. Okay. Okay, so that's 87, 89 over 12. I'm going to knock off from that. 7 and 2 is 9 over 12, which is 80 over 12, which is 20 over 3, which is this one. Great. Another 3 marker in math. That does look interesting. So from 1 to m of that. Oh, do I remember my series sums, though? I can't remember the exact formula, so I'm just going to write out what the first few terms are going to be. So when n equals 1, it's obviously equal to 5. When n equals 2, it's 7. So they're going to be increasing 2 each time. And it's going to go all the way up to 3 plus 2m. In other words, a is equal to 5, d is equal to 2. So it's the sum to m is m over 2 into 2a plus n minus 1d. And that sum is equal to 140. The 2 I'll just divide through right now, simplify. So 5 plus m minus 1 is 140. So we get m into m plus 4 minus 140 equals 0, because I can see this will be a quadratic. M squared plus 4m minus 140 is 0. And I see that that is 10 and 4, so it's going to be m plus 14, m minus 10 is 0. And so m can't be negative, so m is going to have to equal 10. Not too bad. Oh, I forgot to take a split on the last time. Oops. Okay, this is a 2 marker. Now things are going to get a little more challenging. So, because pulleys are just weird. You have pulley, 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 pulley. It looks like things are going like that, and then up, and then down, and then up, and then down. What I know is in every instance, tension will pull towards the middle. So if you pull the free end at distance y, how far will m rise? Okay, what I know is I should really skip this, but okay, here's how pulleys work. Tension always pulls in towards the middle, so I'm going to draw that on each object. So if you're pulling down with a tension T, what's going to end up happening? Or rather, if you think about it, if we pull it through a distance y, if a total of y extra meters has come out of here, that has to have come from all of this rope. But it has to have come from all of this rope. 1, 2, 3, 4 extra loops of rope need to have accommodated for this y. So what's happening is it's going to be y over 4 in each piece of the rope. So each piece of the rope gets y over 4 shorter, so this one has raised y over 4. One way to think about this is, yes, this bit from here to here gets shorter, so it raises. I'll see if I can explain that one better later. I'll come back to that. Let's keep going in the interest of time. So question 5. Okay, these are your stable isotopes. So that's all the following statements that are true. Larger number of neutrons. Well, this has 7 neutrons, this has 7 neutrons. That's not true. Larger mass per unit charge. Well, that's 18 over 8 is more than 2. Because the charge is plus 8 from the protons. So that is true. Let me just check the others are not true, though, because I have time. 8 nuclear charge. That is also true, because that is plus 8 versus plus 7. Has a larger mass. That is not true. No, that isn't true, because the mass is 15 compared to 14. It's good that I read that as all the statements, not just one. No, these have the same number of protons, so I'm happy to lock that in. Yeah, I'm abandoning the split times. I don't think they'll be as helpful. Seed pack contains 100 seeds. When planted, 75 will successfully become plants. But of these, only a third will have flowers. Okay, so 75 will become plants. A third of these will have flowers, so 25 will have flowers. A fifth of these will produce fruit. It cannot be that easy. Okay, I would not expect it to be that easy in the real thing, unless I've just desperately misunderstood this question. All right. I'm just going with it. So 2 black holes orbit each other. Ugh. Well, I've got time. I'm only 10 minutes in, so I feel like I can afford to spend the time on this now. So 2 black holes orbit each other. Periodic nature of the orbit. The orbital separation is around 10. So let's say they orbit around a common center. And I think the diameter is 10, so I'm going to say the radius is 5. The relative speeds of the black holes are close to the speed of light. Frequency of the emission rate. So I think what's going to happen is if these are separated through the center of the orbit, the situation will look identical when they have moved halfway around the circle, because then there will be a star in each of the same positions. So I think the time period will be the time to move halfway around the circle. And halfway around, so it'll be the linear speed. So distance equals speed times time. Distance equals speed times time. So the distance that it travels is not 2 pi r all the way around, but just pi r, which is pi times 5 kilometers. So the distance is 5,000 pi. That's how many meters it moves. In 3 times 10 to the 8 times the time period we're looking for. And the frequency is 1 over the time period. So the frequency is equal to 3 times 10 to the 8 all over 5,000 pi. I could put that in the calculator, but instead I'm going to approximate that to 3. Cancel, cancel for 1. Double up for 10,000, which is 10 to the 1, 2, 3, 4. So I think that's going to be approximately 2 times 10 to the 4, which is that. I am now also going to check the calculator just because I can. I'm going to put a fraction. This is because I'm too zoomed in, so I'm going to zoom out. So 3 times 10 to the 8 all over. And in fact, no, I should really demonstrate how to use this thing because I think a lot of people might be confused by that. 5,000 pi equals, yeah, 1, 2, 3, 4. I wonder if there's an SD function. Can I convert that into standard form? It looks like the answer to that is no, but I'm happy with that. 10 to the 1, 2, 3, 4, it's 10 to the 4 hertz. Okay. Considering a function, I'm going to zoom back in so you can read better. Consider that function. You want to transform it to get a new function stretched by a vertical factor of 2. So I'm going to, with a line of, I'm just going to draw what they're talking about. Line of symmetry, x equals 1. So I know that's where the turning point is going to be, which is never positive, which means it has to be something like that. Oh, okay, no, but it's I think in terms of this, I think it's going to be it's not going to have been dropped. So I think it's going to do something like that. So in other words, it's going to be the negative of x minus 1 squared. So you would have x squared, you make it x minus 1 squared to get it here, and then you flip it so it's never positive. So it's minus f of x minus 1, which you can't see, which is that one. Okay, so 9. Y equals that, what's dy dx? Okay, so I'm going to use the chain rule. So 2 plus making sure I don't write the question down wrong. Differentiate, you're going to get 4 bracket cubed times the differential of the bracket, which is and the 4 and the half cancel to make 2. Oh, don't make me do it. I only just looked at the multiple choice and they want me to expand it out. No worries. It's just a simple binomial expansion. So it's going to be 8. So it's 2 cubed plus 3 times 2 squared times that. In fact, no, I'll write this out in full. So 2 plus x over 2 cubed is going to be 2 cubed is 8. 3 times 2 squared times x over 2 3 times 2 times x over 2 squared and x over 2 cubed. So it's 8, that's 4. Well, that's going to cancel down, so you're just going to get plus 6x. One of these, so if I make that x squared over 4, then that cancels with that to make 2, so I'm going to get plus 3 over 2x squared plus x cubed over 8. But then I need to multiply the entire thing by 2, and then I get this. Because I put that into there, multiplied by 2, and that is dy dx. Yes. Okay. Keeping a good eye on the clock. I'm not yet in 20 minutes, but I'm nearly a quarter of the way through, which is great. What speed does a bull elephant have to move to have the same kinetic energy as a cyclist? Okay, well, let's work that out. Half m. Don't make me. No. Okay, no, that's fine. All right, let's convert from kilometers per hour into meters per second. So 30,000 meters in 3,600 seconds. No, I can't even be bothered. Right, calculator. Fraction, zoom out. 30,000 over 3,600. Thank you. So it's 25 over 3. So half times the mass times the meters per second speed squared. We'll cancel that for 50. Well, I'll keep going on this then. So 50 times 25. Is there an easy squared button? Squared. Over 3 squared. You see, it didn't give it exact, and I wish it had. Okay, but let's instead equate that to a half times m times v squared. So in fact, what I'm going to do is I'm going to cancel the halves, keep that as 100. So v squared is 25 squared over 3 squared times 1 over 4900 times 100. Well, one of these 25s is going to cancel with 100 to give me 4. And now I'm just going to put it in. Right. So 25 over 9. No, let me do this. Okay. Let's not be in ESAT mode. Let me clear that. So let's say 25 squared. So I seem to prefer clicking. 25 squared over, no, not 9 squared. Focus. Don't get complacent. Oh, I really did get complacent. That 100's not on the bottom. Okay, I'm going to rewrite this. Okay, so half m v squared is half m v squared. Cancel, cancel. Okay, so it's going to be 100 times 25 squared all over 3 squared times 4,900. Great. And then I can second square root. Where's the answer button? Is that it? Nope. Answer button? No. Okay, got it. What do I do about the syntax error? Clear? And it, okay. I remember it though. It was 625 over 441. And you square root that, and you get 25 over 21. Okay, so tech is not my friend, but that's 1.2. So yeah, definitely worth getting in and making sure you're good at using the calculator. If you can spot an answer button that I can't spot. Oh, there it was. Okay, so I'll run it again just to show how it would have worked. So 100. I may regret this if I don't have time at the end, but hey-oh. Pacing is something I'm apparently getting complacent with now that the ESAT's over. So that times 3 squared, that, and then I'm going to do square root second that to give me square root. Second minus sign gives me answer. There you go. Which is, oh, I accidentally square rooted again. But I can still see it's the 25 over 21. Let's divide 21. Oh! Oh no, sorry. I'll do it one last time, because again, I've got time, because I really want to get into this. This is the tech side of things. So, okay, so 100 times 25 squared. And this is why you practice. You really want to make sure you know exactly how to use it before you're done with this mock. Okay, so equals that thing. Square root answer is that. And I think this is fraction decimal. There you go. That's how you get your 1.2. Okay, my timestamp that. No, look what happened. It changed my answer. No, I asked for 1.2. Okay. Okay, resistors. Okay, I'm well rewarded. So I'm just going to use my shorthands. So I know that, hold on. Oh, interesting. So it's currents now. So I know if that current is, well, let me call it, yeah, I'll just call it I. So I know it's going to split in half here. So it's going to be I over 2 in each branch here, because the resistors are the same. Then the current will split equally again, because all the resistors are the same. So it's I over 4 here for B. And then going into C is where things get a little more interesting. You expect there to be double the current in the top because it has half the resistance. So I expect it. So it's that and that. What I3 and 2I3. So that sums to 4I3 is equal to I. So it's a quarter in each branch. So that would be I over 4. It would be I over 4 in this branch, and it would be I over 2 in this branch. So A and C should have the same reading, and B and D should have the same reading. Have I done something wrong? I don't think I've done something wrong. Oh, I guess it's not exclusive. Okay, so A is going to be the same as C, and B is going to have the same as D, but maybe one of those is not included. So AB, no. BE, no. ABC, no. AC is included. Okay, so they didn't include BD. AC is an option. Sneaky, but hey, here we are. Let me zoom back in just for ease of reading the question. 12. Particle of mass m traveling freely there can be stopped and okay, so this looks like kinetic energy, and I see FT, so I think this is work done energy. Change the trajectory. Let me just write down. Okay, I'm just going to make sense of that information. So the work done is force times distance, and that work done is to remove the kinetic energy of a half mv squared. What magnitude of force would be needed to change the trajectory of the same particle at the same speed v into a circular arc? So that would be a centripetal force, radius d. So that centripetal force would be mv squared over r. So that's going to be F. I'll call that F2. So F2D is mv squared. And if I divide the second equation by the first equation, the d's cancel, F2 over F, and the mv squareds cancel. No, I'll do it the other way. I'll do it explicitly. So FD2 over FD, mv squared over half mv squared. D's cancel, mv squareds cancel. 1 over half is 2. So F2 over F is 2. So in other words, the F2, the force that we need, is 2 times the initial force, which is that answer. What's the power of the voltage? So we can get the current from that. Transformers. Okay, so let me draw my primary coil and my secondary. NVIP. Ideal transformer, so the power is 3000 on both sides. I'm going to call that the power. That's going to be to the power supply. And that's going to be to the device. So the device voltage is 60. It has N terms on the winding connected to the device. And 20N on the connected to the power supply. So that's going to step up by 20 to make it 1200. What current flows in the winding connected to the power supply? Well, P equals IV. So I is V is P over P equals IV, which means that I is power over voltage. So it's 3000 over that. Cancel, 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 cancel. 5 over 2, 2.5 amps. So you can see they're really not trying to stress you out. They're just trying to see how you can do questions. I see a 4 marker, but again, timing hasn't been an issue, so I'm just going to go for it. Triangle has vertices in 2D Cartesian coordinates. Just going to draw this out. Zero, 1, 1, 2, minus 1, 2. It is reflected in the line y equals x. So that will be, what that does is that swaps around x and y. So then that becomes 1, 0. B becomes 2, 1. C becomes 2, minus 1. And we're going to label that A, B, and C dash. And then it's rotated about the origin by 90 degrees in a clockwise direction. I'm going to draw the vertices in case that matters. So when I rotate that 90 degrees, that'll go to there, that'll go to there, and that'll swing down to there. So that's just a reflection in y equals 0. From the original. Okay. Let me just, in case. Oh, has it inverted? Well, the scale factor didn't. No, it hasn't inverted because it's reflected to there and then rotated 90 degrees. So B dash has ended up there. So it's very much a reflection. And it's very much a reflection in the x-axis, which is y equals 0. I'm satisfied with that. It's almost going too well, so I'm kind of getting a bit suspicious, but because I know this feels a lot easier than what I was told last year's was like. Okay, which ammeter here gets the highest reading? Let's do something similar to what I did before. Well, this is fourth. So what have we got? Okay, here's what we're gonna have to do. So let's consider this resistor array first. So what I'm seeing is that. So let's find that. So 1 over R equivalent is going to be 1 over R and 1 over 2R, which is 2 over 2R, which is 3 over 2R when you add that up. And then the equivalent resistor there is 2/3 R. Connect that with another R. So R1 in the top branch is going to be 5/3 R. R2 in the second branch is going to be 4/3 R. And R3 in the third branch is going to be, that is 7 over 5 R. So in other words, 1.6-ish, so 1.6 recurring, 1.3 recurring, and 1.4. So we know that the most current goes through the one with the least resistance. So that would initially put us on D. So it's not A or E. But this, I suppose let's get them over 15. So the first branch is, let's multiply by 5. So it's 25 over 15R. R2 is going to be, let's multiply by 5 to get 20 over 15R. And for R3, let's multiply by 3 to get 21 over 15R. So that resistance ratio is going to be the ratio of the currents. So the voltage is the same. This is taking, now it's taking too much time on this one. I can feel it. But okay, so I know the total resistance in there. I know the voltage is the same on all of the parallel branches, so I can work out kind of, so V equals IR. So I equals V over R. In other words, V is inversely proportional to R. So I can do I1. This is not very neatly organized, but I1 is going to be V over that. So 15V over 25R, 15V over 20R, 15V over 21R. And then this I1 is going to split such that 2/3 of the current. Well, the point is it's going to split. Sorry, I've been misreading this. Read the question. So, which emitter gives the highest reading? Well, if the current splits, it can't possibly be B or C. So it would have to have just been from A, D, or E anyway. And like I said before, R2 has the lowest resistance, so it would have the highest current. So I'm going to go with D. Sorry, I could have got that a lot faster. Assuming, of course, I didn't get anything wrong. Okay, so rewarded with a nice math question to make me feel better. So I'll combine those logs and say that log 2 of 2x squared plus 3x, using my log laws to multiply the arguments, is equal to 1. And 1, as we know, is log to base 2 of 0. So 2. Why have I forgotten how to do my logs? Well, okay, so because it's the morning and I haven't eaten. I should have learned that lesson. So x is 0 or minus 3 over 2. Which is not an option. So maybe probably did get that wrong. So I think what that should have meant. Oh, I'm an absolute flaming moron. If it is, oh God. Log 2 of 0. Imagine taking logs of 0. Okay. Come on now. Be better than that. It's all right to make a silly mistake as long as you catch it. Okay, so of course what that should have meant, brain fart, is that 2x squared plus 3x, I think, is equal to 2. So log 2 of 2 is 1. Brain farts are okay as long as you catch them. Minus 2 equals 0. 2x and x. So it's going to be plus 2 to give me plus 4x and minus 1. X is equal to a half or minus 2. Is there a reason? Haha. You cannot take the log of a negative number, so negative 2 does not work. So the only valid answer is a half. Okay. Uh, 17. Gravitational field strength, G is equal to Gm over r squared. Let me just write that down. So at a distance RE, it is 10. Gravitational field strength of a surface is 10 at that distance, and at some distance r, the field strength is 2. Well, what I know from this is that from proportionality, I know that gr squared is a constant. And I can use that here and say that G1, so similar to gas laws, I really like that in proportionality. G1 R1 squared is G2 R2 squared. So it was 10 RE squared is 2 at R squared. And we want the radius, we want RE in terms of R. So RE squared is R squared over 5. So RE is R over root 5, which is that. Okay. So 18, y is sine of 100 over x. For x is bigger than 0.1. Well, if x is bigger than 0.1, the smallest x can be is 0.1, which means that the largest this argument can be is 1,000. And we know as x tends to infinity, that will tend to 0. So this angle that goes into sine lies between 0 and 1,000 in degrees. How many maxima occur? Well, let's draw it out. Well, in fact, we know there's only one maxima per 360. Let me just draw some stuff. So that would be up to 360. That's 720. And that's 1080. So you get 3. Okay. Because I'm assuming, yeah, there's no 6, so it doesn't include. Okay, cool. Wavelengths. Well, I know this is electromagnetic, so shortest to longest. I know it's going to be gamma, X-ray, UV, visible, infrared, micro radio. So an electric torch is going to be visible. That's what one is. Microwave oven, unsurprisingly, microwaves. Radioactive source is gamma, that's 3. Hot stove is infrared, is 4. Radio transmitter is 5. From shortest to longest wavelengths is 31425, which is that. So this is my halfway mark, and I'm good on time. I've so far used 40 minutes. Great. So particle type, equal probability into Y or pair of particles of type Z. Both stable. The decays of two X's are observed. A pair of Y's. Okay, a pair of Y's or a pair of Z's. Okay, so I'm just going to two-way table this. So you can either get YZ there for the first or YZ for the second. In all three of these cases, you would get a pair of Y's observed, at least one pair of Y's observed. What is the probability the pair of Z is among these decay products as well? Out of these three options where Y's are observed, two of those three also have a Z. So I'm going to go with 2, 3, although I understand that that would be counterintuitive. But two-way tables are really, because probabilities, especially conditional probabilities like that, really mess with the mind. And so I find that two-way tables are the best way to just make sense of that. So three options in which a pair of Y's are observed. Two of those three options have Z's as well. So 2/3, given this conditional, we'll have a pair of Z. Okay. 10 students need to complete their compulsory practicals. So in total, 2, 8, 12, 22 practicals need to be completed. A maximum of 6 students are allowed in a lesson. Minimum number of lessons required should in theory be 4. Can it be done in 4, though? Because 4 students need to complete 3. Maximum of 6 students are allowed. Yeah, because if these 4 were in the first 3, I think that should be fine. I can't think of any reason. Let me see. I've got time, so let me see if I can come up with a reason why it wouldn't work. Is that going to be worthwhile? I'll flag it to come back to if I have time to explain it. But my initial reasoning feels okay. Is there going to be a reason why it wouldn't all coordinate up? I don't see why if there's 6 students allowed in a lesson. So the first lesson could be these 4 and 2 of these. The second lesson can be 3 of those and the other 2 of these. And then you have 10 people all needing to only complete 1 practical left, which you can do 6 of them in the first session to get them all like cleared out of the way. And then the remaining 4 would be the fourth. So I can definitely do it in 4. It can't be done in 3 because there's 22. Yeah, done. Okay, fine. Next in this sequence, these are prime numbers. 61 prime. Wow, this is a good time to talk about how you test if something's prime. So, if something is prime, you actually only have to test all of the prime numbers up to root n, which is a good little rule. So we know we only have to test the prime numbers up to 7, because 64 squared would be 8, which is even overshooting the mark. So we're going to test the prime numbers up to 7. Does 2 go into their no? Does 3 go into their no? Does 5 go into their no? Does 7 go into their no? So 61 is prime, and it is the next prime. So it's next in sequence. Stone of average diameter, say with the hammer splits to pieces. I remember this question from last year. Okay. Every time the stone or one of its pieces is hit, it splits into a further 3 pieces of equal volume. So this is going to be similar shapes for length, area, volume. If the big to small ratio in the volume is 3:1, then it's the cube root of 3 in the length, including the diameter. So the size of a typical atom is 10 to the minus 10 meters, and it started from 10 to the minus 2 meters. So the length needs to go down by a factor of 10 to the 8. So I need 10 to the 8 to 1 in the length. And this happens every single time. So every single time that you hit the stone, the diameter reduces by a factor 1 over the cube root of 3. So in other words, every 3 hits, the diameter becomes a third of the original diameter. And how many times would I need to do that before I get 10 to the 8? I'm going to use my calculator. I'm going to need to consider, well, I suppose a better way of doing this would be if every hit that's that factor, then after n hits, diameter would go to, that is 3 to the minus a third minus n over 3. And I need this factor of 3 to the minus n over 3 to be 10 to the minus 8. So why don't I take logs, because I know that's a function I can do. So if I take logs of both sides, minus n over 3 log 3 is that. Cancel the negatives. So n is equal to 3 times 8, which is 24 over log 3, which I can type into the calculator. 24 all over log 3, which is not an answer. Okay. I'm going to flag this one. I'm going to come back to it because I want to at least demonstrate that functionality. So I'll hold off on that because I remember I just, that for some reason just messes with my mind, that question. Okay, so if A is a constant less than B. Oh, no. Okay, so here's how to deal with multiple X transformations. So I'm going to rewrite the current argument as X dash, and I'm going to make X the subject of this equation. So A minus X dash is X. So what this means is I take my original X's and I do A minus the original X's to get the new X's that they transform onto. So in other words, what I know is that if that was 2B, that will move to A minus, well, this will move to A minus B, which is negative. And it will be down there. So it will be something like this. And that 0, A minus 0, which is positive, so it will look something like this. So that'll be A minus B, A minus 2B. And the only one that looks like that is E. So this is a helpful technique if you're ever trying to work out multiple X transformations. There are probably better examples to show that, but yeah. And then it's, yeah, I'm confident with that. Okay, next. Next number in this sequence. Why are these so easy? You're dividing by minus 3 every time. 12 divided by minus 3 is 4. Again, I'm going to zoom in. I should always remember to do that after I use the calculator. This. I'm going to call log. Yeah, I'm just going to rewrite it just for speed purposes. So that's, well, I'll call that 5 log 2. From understanding that 32 is 2 to the 5 and bringing the 5 out the front. So a minus b is minus log 2. Just going to subtract the equations and get 3b is 6 log 2. B is 2 log 2. And then add that across. 2 log 2 minus, so a is just equal to log 2. Which means, given that, and that's log 4. So that means that x is equal to 2, y is equal to 4. And to be honest, if we look at this, you can't take the log of a negative number. So it can't have been this one, or this one. The only possibility was x is 2, y is 4, or no solution exists. And at that point, you could have just plugged them in and trial and errored it. So they're picking easy questions. I think a lot of this is just to get used to the format. I say they're picking easy questions. This is also a question I recognize because everyone hates it. So I'll walk through how this one should be done. I don't think I've seen it in a year, so let's see if I can still navigate it well. Consider a system of many interacting particles. Okay, so potential energy is r to a power. I know that potential energy, though, is inversely proportional to r. Because interacting particles, they interact through electrostatic attraction. And so that's going to be electric fields. I know that the force is an inverse square law, and I know electric potential is an inverse law. So I know this is true because of how particles interact, which means that n is equal to -1, which means that 2 is minus v. So I know that whatever that means is mathematically this, which means that, well, that T is the kinetic. And I know that the total energy is potential plus kinetic, which is, in terms of V, and then T is -1/2. So it's a total half V, which is this one. But yeah, the leap was understanding what that potential relationship is going to be. I'm going to use my before and after case here. So before and after is what I use to divide through and cancel. So if I know that G Earth is G times M Earth over radius of Earth squared, and I know that G of the planet is equal to G dash mass of the planet all over radius of the planet squared with substitutes and values. So G dash has twice G. For a planet in the different universe which has half the radius. So the radius of the planet is half the radius of the Earth. But it's in terms of density. So let me do some work on that. So mass is density times volume, which is density times 4/3 pi r cubed. Now, why does that matter? In fact, what I can do is to sub that in to say that G is GM over r squared, but that is g times 4/3 pi rho r cubed over r squared. And that cancels down to g just being equal to 4/3 pi rho g r. So I'm going to do that instead for the Earth and the planet. So g of the Earth is 4/3 pi rho of the Earth g times r of the Earth. G of the planet is 4/3 pi density of the planet g dash in that universe times the radius of that planet. I know that the density of the planet is twice the density of the Earth. I know that g in this universe is twice the value of g in our universe. And I know that rp is a half the radius of the Earth. So if I do gp over ge, the 4/3 will cancel, the pi's will cancel, the densities will cancel, leaving me with a factor of 2. The g's will cancel, leaving me a factor. In fact, I've got time. Let me show you how all this works. So at this point, dividing is really good because almost everything cancels. So just rewriting the equations. Density of the Earth, GRE. 4/3 cancels, pi cancels, density cancels, g's cancel, re cancels, and you just get is 2 times 2 times a half, which then is just equal to 2. So planet over the Earth, you're going to get 2. And I like that. I like writing a before and an after, dividing through, canceling constants. In which range of alpha does this have real solutions? Okay, so that's sec squared, and I know sec is related to tan, so that's where I want to go with this. I'm not sure if that's on the spec, though. So sec squared theta plus alpha tan theta is 0. I can never, ever remember my equation, so I have to start from sine squared plus cos squared equals 1. I'm going to divide through by cos squared to get the tan squared plus 1 is sec squared. So that means that tan squared theta plus alpha tan theta plus 1 equals 0, which is a quadratic in tan theta. And this needs to have real solution. So we need to have the discriminant being bigger than or equal to 0, and the discriminant is b squared minus 4ac, and that has to be bigger than or equal to 0. So then if we sketch that, alpha squared minus 4 crosses at minus 2 and 2. It's got to be bigger than or equal to 0. So we need alpha being less than minus 2 or alpha being bigger than 2. I just want to consider whether there would be any problem. I don't imagine there would be. I'm going to stick with it. Well, I'll be able to see if my instincts are wrong, and I'll be able to get diagnostic feedback from that. So a bag contains B blue balls, R red balls. 2 balls are picked at random and removed from the bag, that they are different colors. Well, there's 2 ways of doing that. So it's the probability of getting a blue and then a red, and the probability of getting a red and a blue. So it's blue and red, or red and blue. So in probability, when things are mutually exclusive and independent, and means times or means plus. So it is blue times red, which is now going to be b plus r minus 1, plus red times blue. So it's going to be 2br all over, well, it's going to be this one. 2br over b plus r minus 1. again, this looks quite small. So the typeface isn't great on that. I can see it well. Hopefully you can see it well. We wish to represent integer numbers by using our 10 fingers. Fingers assumed to be either stretched out or curled up. How many different integers can we represent with our fingers? Now, this is complicated, but if you've seen it before, it's not. And this is going to be using a binary system. In a binary system, if you think about what the numbers represent, so you get 0, 1, then you get 1, 0, 1, 1, then you get 101, 100, 101, and 111. And basically, there are two options for each of the digits. Which means that the number of numbers you can represent with n digits is 2 to the n. So when you had 2 digits, when you have 1 digit, you can represent 2 numbers. When you have 2 digits, you can represent 4 numbers. When you have 3 digits, you can represent 8 numbers. And this holds. So I'm going to be able to, so I can represent 2 to the 10 numbers with my 10 fingers, and 2 to the 10. I know it's 1084, but I don't need to know that because I can do 2 to the power of 10 and get that as 1024. So it's complicated, but that's what you can do. Okay. Okay, so this is right-hand grip rule. If the current is moving up, then it creates a magnetic field in a circular orientation in the plane. I'm just going to write them like this. And it's going to curl around like that. So in this position, it's going to be going there and out of the page, and here it's going into the page. And apparently that's the magnetic flux. Cool, whatever. Circumferential around the wires. Second identical wire is placed parallel to the first at a distance d. Find the current that has to flow in the second wire if the flux density, the line halfway between. So let's say this is halfway in between. If it's going to double, then it has to reinforce. So I know, for instance, for sure, that has to be going that way, that has to be going this way. So if the current here is moving up to cause it moving that way, the current must be moving down in this one to cause it moving in the other orientation, which means it has to be negative. And this is a point halfway between these. So the distance to both wires is the same. The magnetic flux here from the first wire is alpha I over, well, let's call that d over 2, because that's what it is. That, for it to double, it has to be the same thing here. So in other words, if I rearrange this, no, so how do I explain this? I completely understand this, but can I explain it? Let's find out. So this 2 alpha I over d is the component of the magnetic field from the first wire. In order for the magnetic field to double here, that must be the same as the component at that point from the second wire. So that is also alpha I2 over the distance from this I2, which is d over 2, that 2 comes to the top, everything is the same. So it has the same magnitude in the opposite direction, so the answer is this. Pat Test is obsessed with these. I don't know why. They love a good eclipse. When the phase of the moon as seen from the Earth is full. So if the sun is here and the Earth is here and there's nighttime and it's looking at a nice full moon, what is the phase of the Earth seen by the observer? So if you're on the moon, you're looking at a bunch of like the dark side of the Earth. So it would be this. All the resistors have the same resistance R. Light bulb has a fixed resistance. Change the state of the switches so the brightness of the bulb increases from its minimum to its maximum. Well, it has a constant resistance. So for the P equals I squared R. So if I decrease the current, I decrease the brightness. If the brightness increases from its minimum to its maximum, that means the current in here increases from minimum to maximum. The minimum current. Well, let's discuss what these different resistance branches would do. So these two, 1 over R plus 1 over R is 2 over R. Flip that around, this becomes R over 2. And that one would basically make that into 3R over 2. And on the bottom branch, we have 2R. If I were to close, and then let's consider the overall, if current is allowed to flow through both. So flip the top, flip the bottom. Let's get them both over 6R. So that's 7 over 6R. So in other words, with just A closed, the resistance is 3 over 2R. With just B closed, the resistance is 2R. With both closed, so current able to flow through both of them in a parallel fashion, it's 6 over 7R. So again, what we want is to go from, if we want the brightness to go from minimum to maximum, that means we want the current in the bulb to go from minimum to maximum. That means we want the resistance to go from maximum to minimum, which is B followed by A followed by AB. And that kind of very rigorous logical walking through is good for interview, but it's also good in Pat. Assuming, of course, I got that right. Time will tell. I just don't like, these questions, but that's fine. I can still do them. So it's an open closed pipe. That's the lowest. So the wavelength, if that is length L, that is a quarter of the wavelength because it goes up, then down. So it goes maximum, then to equilibrium, then to minimum, then to equilibrium. So lambda is 4L for that distance being L. V equals F lambda. Which is 4FL L is equal to V over 4F, which is this, which is not too bad. Which combination is the odd one out? If memory serves, I don't like this question, and I'm about to find out why. I don't even know what a Coulomb times the speed is. So I'm gonna just ignore that for now. Well, kilogram meters per second. That's a mass times an acceleration, which is a force. So I'm going to write out my options. So that reduces to newtons. Work done. So that's a force. I know for this one, for the equation, the fourth one I want, work done is force times distance, which means that force is equal to work done over distance. So it is joules per meter. So that is also a newton. I know for this one, F equals BIL, where B is measured in Teslas, I is measured in amps, and L is, so that is also force. That's a newton. This one, well, a volt times the current is a power. So that is joules per meter per second. But joules per meter, so that is definitely not the same as this, and this is the same as everything else. So I'm going to say that. Why is the first one a force? Because charge per unit time, that's a current. I wonder, if force is equal, if that's from voltage. So force is equal to the electric field strength times the charge. Well, that's newtons per coulomb now. I bet it comes from there, you know. I've got time, certainly. So let me see if I can find it. I'm sure it's this one, though. By process of elimination, it has to be that one. Just because it's incompatible with this, which is the same as everything else. What is that? Accelerated through... Well, I certainly know... Okay, let me put it this way. If I accelerate an electron through a distance d in a voltage v, I know that voltage is work done per unit charge. So the work done on that will be voltage times distance, and that will be equal to half mv squared. No, I'm struggling to find the explanation here, but I'm gonna stick with that just for process, like just good exam practice. In fact, I'll come back to it to see if I can find a better explanation. But so 90 people enter a maze. At each junction, a third will go left and 2/3 will go right. After 3 such junctions, I'm just going to tree diagram this. Nothing to it. So left, right, I should really have left a little bit more room, but whatever. Right, left, right, left, right, left, right, right. So 1/3, 2/3. On each branch. Apologies for the silence, but writing is not super entertaining. This is just a bit tedious, but okay. After 3 such junctions. So, in fact, I shouldn't really have considered that. What I should have done is just gone straight to this. So what are the possibilities? I mean, these are all the possibilities. I should have just gone straight there. Apologies. So going right 3 times is 2/3 cubed, which is 8/27. Going left 3 times is 1/3 cubed, which is 1/27. And in fact, we can kind of do this as a binomial expansion, where there are 3 attempts, and the probability of going left is 1/3. So we can consider the probability of going right twice and once left. That's the probability that x equals 1. Which is 3 choose 1. You succeed once and you go right twice. So it's 3 times 1/3 times 4/9, cancels 4/9, which is 12/27. That's where x equals. So that's the probability of going right twice and once left. And the probability of going of x equaling 2 is choose 2. You go left twice, you go right once, where that is also 3, which cancels with one of these, and you end up getting 2/9, which is 6/27. So the most probable, so it's 1/27. So going right 3 times is 8. So out of 27, going right 3 times is 8, going left 3 times is 1, right twice once left is 12, which is the most probable. And then this is 6. Cups of tea. The first cup the person drinks is filled completely. Too much tea in total. It's filled with only a fraction of the tea of the first cup. Same fraction in the cup, and so on. What is the maximum value of alpha so that the person drinks no more than 3 times the amount of tea in the first cup? So this is a geometric series. So the first cup is A, then we have AR. Well, yeah, I'll just do this in R and recognize that R is equal to alpha, AR squared, etc. And we want the sum to infinity, which is A over 1 minus R. Drinks no more. Well, the maximum value is going to be the limiting case, which is where that sum to infinity is exactly equal to 3 times the amount of tea in the first cup, which is 3A. Cancel the A's. And 1/3 is 1 minus R, so R is equal to 2/3, which is this option. Still 40 minutes left. Rectangular building, sides 50, 100. Flat times roof. Top of it. Roof has a mass per unit area. Well, what's the area? 5,000 meters squared. Mass per unit area is that, so the mass is that times 100. 1, 2, 3 with another 2 zeros, that many kilograms. Do I literally just multiply that by g? Is it okay? So in fact, so it was 50 times 100 is the area. Area times 100 gives you the mass. Times 9.8. 1, 2, 3, 4, 5, 6. I think it's just that option. So again, it doesn't feel like they're picking representatively difficult questions in this mock. I think it really is. I'll analyze at the end. What is the equation of line that intersects this position? Okay. Okay, so when x equals 1, y equals 0 on this line. If I draw this line, it's going to do that. We want it to be perpendicular. So the gradient is going to be minus a half. And this point is 1, 0. So y minus 0 equals the new gradient of minus a half, x minus 1. So y is minus a half, x plus a half. Okay. I'm going to go to the Navigator. I want to test the platform. I think when I go next, it should send me to a review page. Yes, it doesn't tell me correct or not. It just tells me complete or incomplete. Oh, I didn't realize I left that many incomplete. I hadn't flagged them. I did do this when it was 10 to the 4. That's curious. I wonder why I didn't submit question. And this is why it's a good thing we've kept this. I'll remember this diagram as well because it was just a big old circle. I didn't keep the questions too well. Yeah, it was 10 to the 4. Okay, let's go back to the review screen. I also didn't submit 22, which I thought I had, which was 61. I totally clicked 61. Apparently not, because that was the next prime number. All right. So that was weird. So you can learn from that. Apparently, it's possible to totally think you've submitted an answer and you actually haven't. So always check before you submit. So I'll review this one. Yeah, I didn't like this one. I never liked this one. All right. So I'm going to just do it clean because again, I've got 36 minutes, so why not? Okay, hit with the hammer and split into pieces. So I know 3 further pieces of equal volume, which means that the volume goes to V over 3 with each hit, which means a length will go to length over the cube root of 3 with each hit. Okay, I'm going to do this in approximate fashion. I know after 3 hits, let me get a rough sort of back of the envelope calculation going. I know after 3 hits, the length is going to go to L over 3. So I know after 6 hits, that is going to third again to go to L over 9, which I'm going to approximate as being 1 over 10. Oh my god, I'm a flaming moron. No, because it was 10 centimeters. That wasn't 10 to the minus 2. It was 10 to the minus 1. Okay, let me go back and see if I can find that working. That was 23. I remember, yeah, length, area, volume. So it wasn't 10 to the minus 8. It started off on 10 to the minus 10. It went to 10 to the minus 1. Okay. Right. So it actually means that that thing should have been 10 to the minus 9. That should be 9. That should be 27 over log 3. Let's see if that comes out clean. 27 over log 3. 56. Boom. Okay, so that is an answer. I'm going to lock that in, but I'm going to explain my back of the envelope method because this would be more helpful if, for instance, you ever saw something like this in an interview situation where you don't have a calculator. So what you would do, so 3 hits takes you to L over 3. So another 3 hits will give you another factor of a third, which takes you to L over 9, which is approximately L over 10. Back of the envelope. We're physicists, we make assumptions and approximations. That is okay. So if I want to go from 10 to the minus 1 to 10 to the minus 10, I need to do that 9 times. 9 times 6 is 54, so it's approximately 54, and that's why you can pick 56. So let's unflag that. I have all of the questions answered. There were a couple flagged for me to explore or expand on. No, this one I totally did explain it. I don't need to, because I did the worst case scenario. So these four, in fact, well, I've got time. I'll just write them all out. So I'll call them A and B need to do 1. C, D, E, F need to do 2. And what's the rest of the alphabet? A, B, C, D, E, F, G, H, I, J have to do 3 each. So I can show you exactly what those 4 classes have to be. So G, H, I, J pair off with C and D. G, H, I, J pair off with E and F. Now these guys have done 2, so they have 1 left, all of them. These guys have done 1, so they have 1 left, all of them. These all have 1 left, so then I can just do A, B, C, D, E, F in the next class, and then they're all done. And then G, H, I, J, wrap up. And that's done in 4. So that is completely fine. Did I find a... Yeah, I just want to find that. Just for peace of mind. What am I missing? Which combination of units is the odd unit out? I don't know what that is. Coulomb? What affects coulombs? Force and charge. So electric field. Electric field is KQ over R squared. Don't know the units of that. Why is that a force? F equals, maybe F equals BIL. I can rearrange that. Oh, no. No. No, because that's feels electric. Okay, why don't I try this? Why don't I try force is electric field strength times charge. Well, electric field strength is force per unit charge, but it is also V over D. So F is equal to QV over D, where V is a voltage. Voltage, it's work done per unit charge and the charge cancels. All right, I'm going to lock that in, though. I really do believe it's right. So I'm apologizing that I can't find this off the top of my head. I'll see if I can find an explanation, stick it in the description, or a pinned comment. But in the meantime, I've completed them all with nothing to review. I've still got half an hour left. What does that mean? Oh, I don't want to do that. Let me zoom out. Oh, wait, they're not going to mark me, though, are they? I don't think they mark me. How will I know if I got them right? Excellent point. Let me see. Oh, don't make me mark myself. Like, that's going to take so much time if I'm going to have to find out the source of all these questions. Let me see if I can quickly find a mark scheme. Because I have a feeling once I submit this, it's going to like end. Um, did not think that through. Pearson Vue at practice test mark scheme. 2024 specimen paper. Is it this one? Okay, it is this one. Okay, good. All right, so what I'm going to do, we're going to do a review all. Let's see if I got them right. So this one I got correct. This one, well, in fact, what I'm going to do, let me take this, stick it here, and then resize this. Okay. So this, it's marking as correct. This is marking as correct. Now, this is important. They do reorder the, so you get the same questions, but they reorder all the answers, which makes it harder for you to look over and cheat. You can't just see, oh, that bubble was filled in and fill in the same bubble because it's not going to correspond to the same answer. So the answers are in a different order, but I got the right one. I got 10. I got y over 4. This was one I should probably have explained a bit better. So, but that's kind of what they did. If this y comes through, that y has to be distributed between these 4 different sections of rope, which is why you get that y over 4. It has to, the same amount comes out of each of them. Now, another thing, I didn't explain it because it wasn't necessary for this question, but if there's a tension here, you saw me start to draw this actually. If I zoom out, scroll back to the top. Look, come on. There. You can see me start to draw these tensions. What it means is if I pull with tension T, we can see there are these 4 upward arrows acting on the system, which means that if you pull with tension T, a force of 4T acts on this mass, which is why pulleys are good at sort of force multiplying. It means you can lift something very heavy that you wouldn't be able to lift on your own. So I think that's just interesting to explain. But that's why it was y over 4. Did I get this right? Larger mass per unit charge, larger nuclear charge, larger mass. Yes, at least according to this. 6. The answer was 5. So easy. 10 to the 4 for the reasons I explained. So yeah, I think I explained that well enough the first time. 8. Oh my god, I didn't go back and check. That was bad exam technique. I forgot all about this vertical stretch by a factor of 2. That's on me. That was poor. Okay. I should have clocked that. So I did understand what was happening. I just didn't read that. Okay, so I got one wrong. So the lesson from that is to just, before you submitted an answer, especially if you've got time, because that would have been really frustrating, is just reread the question and make sure you've considered everything. So here I did consider everything. 1.2, yeah. And that was where we used the calculator. A and C, yep. And it was also right that B and D were the same. 2F, yeah. 2.5 amps, correct. And exactly, just laying out the primary and the secondary, or as I labeled it just more directly, power source device. 14, reflection y equals 0. 15, yep, D. And again, I really could have done that one faster. 16 half. I'm glad that I went back and I considered the fact that it couldn't be x equals minus 2. So that was one where if I'd applied that same headspace to the previous one, I wouldn't have got that one wrong. R over root 5, yep. And I used exactly the same method of equaling a constant, Earth equals, planet. That's used a lot in physics, this before and after. So it's something you pick up for the first time when you're doing gas laws. If PV equals constant, then P1V1 equals P2V2. But you can do that literally anywhere in physics where there's any proportionality. Great technique. So this looks really complicated until you consider what this means for the argument. So it's just between 0 and 1,000. Three, 1, 4, 2. I like the way I did that. I do not like the order. I like to put my short wavelengths on the left. 2/3. Yep. And I think this is best explained actually the way I did it with a two-way table. 4. Yep. And I showed all the cases. 20, 61. There's just, primes. And I look at how I did that, by the way, for how to establish whether something is prime. If you haven't got it memorized, you check up to root n, all the prime factors. By the way, if you're wondering why that it should be the case, let's consider so let's take 36, for instance, and let's get the sort of factor pair. So it's 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And you can see these factor pairs, the numbers in the factor pair are getting closer and closer until you get up to here. But once you get up to root n, then the numbers start going up on the other side. So once you hit root n, you stop hitting the left side pair and you start going up the right side pair. So for instance, let's do 24, which is not square. It's 1 and 24, it's 2 and 12, it's 3 and 8, it's 4 and 6. And root of that is roughly 5. So once we go past 5, the numbers start going up the right-hand side and they start pairing up with the factors we've already got. So in order to find the number of pairs, you only need to go up to root n to see if a factor pair exists. So for 61, we checked all the known ones from 1 to 7, and then anything from 8 onwards would have gone up the right-hand side. So the only factor pair we had was 1 and 61, so it was prime. Really helpful technique, that. Okay. 23, 56. Yep, I've done that multiple ways now. So this, I like my technique of considering the multiple x transformations. Take that, set it equal to x dash, make x the subject, and that tells you what to do. So to find my new x, I would do a minus x dash, where x dash is the original. And it works every time. 25 is 4, self-explanatory. Self-explanatory. This one I think I went through in good enough detail. This was too good. They didn't submit an answer, but he got the same as me. Yep, that's the same. 1024. Okay, so yeah, really difficult if you haven't seen binary, really easy if you have seen binary. There's another Pat question which is super annoying, which looks like this, but like the long form old style question. Did I explain it well enough? Can I do better on that? Let me try this. Let's consider our normal number system. So with 2 digits, so with 1 digit, I can go, if I can put 10 numbers in that, I can consider everything from 0 to 9. So there's 10 possibilities there. With 2 digits, I can do all the numbers from 0 to 99, which gives me 100 possibilities. With 3 digits, I can consider all the numbers from 0 to 999. So that is 1,000 possibilities. And you can see that for the number of digits, it is 10 to the number of digits, 10 being the number of digits I can place in each slot. If instead I could only place 2 digits in a slot, 0 or 1, then I would get exactly the same idea, but it would be 2 to the n. And here, 10 fingers means I have 10 slots. That would be 2 to the 10. In each of my fingers, I could submit a 0 or a 1. I think that would work. As an explanation. Did this work? I hope so. I hope you can see that here they have to reinforce and they have to be identical. So it has to be exactly the same field, but in the opposite direction in order to be reinforcing with the same amount from the same distance. If the distances are different, that's when maybe the currents would have been different. But because they're equidistant, then the currents must be equal in magnitude, but opposite in direction, so that the arrows are reinforcing in the middle. This, I think, is pretty self-explanatory. Although they can ask harder versions of Eclipse questions. This, I hope I got right. Yeah, B, then A, then that. I think I walked through that in a very systematic fashion, so happy with that. This was almost too easy. This, oh. Oh. Maybe that's why. Oh, no. Oh, I didn't even think of it from that perspective. All right, that is just a conceptual error. That is just me not even considering that as a possibility. I should have, though. All right, so what I did wasn't bad, given that I couldn't work out what this even was as a quantity. Because it seemed, because they were all reducing to newtons, so it felt like they were all going to reduce to newtons. So I'm not even mad about what I did in that situation. But understanding that, wait, SI base units. Is Coulomb not a base unit? Hang on a minute. This is... Apparently amp is the base unit. Okay, so Coulomb is not a base unit, but amp is. So Coulomb is actually just an amp second. Good to know. Okay, so that is something if I'm going to move forward, I got to brush up I got to finesse exactly what I consider my base units to be. So, okay, that's good for me to revise. Voltage, obviously not. That's work done per unit charge, and you can reduce it from there. Joules, force times distance, you can work from there. Yeah, okay, clever. Just didn't consider that. So that's one conceptually wrong, one exam technique, because I got that. I executed that other one previously perfectly, but I just didn't read the question and forgot about that factor of 2. So this, I think I explained fine. This was fine. This was almost too easy. And yeah, that was fine. Okay, so now I'm curious to see what happens when I click submit test. Yeah, they just ended the test. So this really was just to get it used to the format. Okay. So I'm going to stop sharing screen. So let's discuss. I think the questions were a lot easier than you're going to get in the real thing. I think they selected quite simple ones from the past papers. where they will have pulled them from is all of the multiple choice from the previous PATs. So they've changed the format up a lot over the years. But typically papers will have somewhere between 3 and like 12 multiple choice questions. What they've done is they've just stolen those, put them in, assembled a paper from it. They changed it last year to be in this new format where the 3 markers are supposed to be hard and the 4 markers are supposed to be very hard. And my understanding is last year was conceptually a lot more difficult than those questions were and was a lot more time pressured. So in the real thing, I would advise you to keep a close eye on the clock. Like I was doing every now and again, I was like, I've got this much time left, got this much time left. But also keep an eye on whether the work you're doing is working. If you're getting stuck in the mud, it may be worth moving on from that, flagging it, coming back to it later. If you got the time, just make sure all of your work is productive work. So go through, but like I say, it's kind of not as bad as the ESAT in terms of timing. So hopefully the most important thing there is use of calculator. Go make sure you've used that, because I was stumbling around. Like I knew how I would want to do it with my physical calculator, but doing it on that screen version was weird. Just sort of working out where all the different buttons are. Definitely worth going in and playing with that. In terms of conceptual stuff, there's not too much in that paper, I would say, that was necessarily going to move the needle when it comes to your PAT. But I think showing you how to move through the interface and use the calculator is sort of worth doing. Make sure you get that done. And then to prepare for the PAT, you can do every multiple choice from every paper that's ever existed. And I also highly recommend NSA. Let me see if I can find this, actually. I can share it with you. The NSAA past papers. NSAA past papers. The section 2 from 2020. The reason why is because if I start sharing screen here, so what you see here is you have 20 questions in 60 minutes. So 3 minutes a question. It's exactly the same pacing as the PAT test. And it's got some good challenging physics in it, particularly as you move towards the end. So here, this question is significantly harder than anything that I just got shown. So it may be worth going through those NSAA section 2s to just meet some challenging Oxbridge level physics at the same pace that you would do the PAT test. I think that's what I'm advising all of my guys to do. And I think that's about it. So yeah, hopefully you found that useful in terms of just moving through the interface. I think by this late stage, you've probably already revised a lot and you kind of know what you're doing. But yeah, so if you find that helpful, it's probably going to be the only PAT that I do for this year. I might do more next year if I get more PAT students. Right now, I only have one who's already sort of well-established, kind of knows what he's doing. So keep posted for interview skills and for TMUA stuff. And I'm going to do some more ESAT, I think. Because I've done some of the papers, but I can go back and do the rest of the papers demonstrating more of that skill set for anyone doing the ESAT in January. Okay, I'm going to leave it there. Work hard, have fun. I'll see you next time.